Okay, so we are looking at some geometry. This question could be a matric question if you're in South Africa, or it could be a GCSE question or an easyish AS level question, where we've got a circle and here we've got two tangents, DA and AB. We've got the center of the circle, O, and so just looking at it, we can say a few things. If O is the center of the circle and this AD is a tangent, we know that these are 90 degrees, right? Let's do it in a different pen, so let's do that. So we just know that those are 90 degrees, these two angles here. Let me just do them in different colors. And that's because your tangent is perpendicular to your radius. Yeah, we've got a lot of things here. We've got these lines are equal because tangents, when they go to a common point, DA and AB would be equal. So DA and AB would be equal because of tangents to a common point. And so we could work out this angle here in yellow. These two angles in yellow would be the same because you've got an isosceles triangle now. You know that that's 48. And then from there you could get this angle because you've got a cyclic quad here. But yeah, there's a lot of things you could get. So let's just see what they've asked first. So we've got ABD. They want to know ABD. Okay, so that yellow one. So we know we can get that yellow one. So we can say now, do they want reasons? No, but let's just do reasons for practice, right? So AD equals AB. Tangents to a common point. That common point, by the way, is A. And then, so you know that's an isosceles triangle, so you know that B and D are equal, right? So ABD, well, ABD and BDA are equal. ABD equals BDA equals, and then so we say 180 minus 48, so 132, divide that by 2, and we get 66 degrees, right? So I think that they just want the thing because they haven't left a space for the reasons. But that reason would be angles opposite equal sides, because those two sides are equal. Okay, let's look at OBD. OBD. Okay, so let's see. OBD is also 90 degrees. That's for the same reason we gave that, these are equal because you have a tangent here going to the radius of the circle. So tangents to the radius, so AB is the tangent, O is the center, and so that's 90, and this is 90. Okay, so they want OBD. Okay, well, we know that OBA equals, so we don't have to give reasons, but we know OBA equals 90 degrees. So this is just to show how we get it, right? And that is tangent perpendicular to radius. Okay, because OB is the radius of the circle, AB is the tangent. And so we could get it by subtracting. So if that OB, the orange one is 90 and the yellow one is 68, then the small one is going to be 90 minus 68. So OBD equals 90 minus 68, which is 22. Okay. BCD, BCD, BCD. Okay. Well, how do we get this one again? So they're wanting BCD, this whole in purple here. Well, all I need to do is, I know that pink is a right angle, and if I, and so if I get, they want OBD, they want this one here. Oh no, wait, we just got that one. So they want BCD, BCD, they want that one. Okay, well, if I get the two that I'm going to color in green, if I get that one and that one, I can subtract those from 180 together because it's a triangle, right? This is a triangle here. Okay, I'm going to delete that so it's not too messy. But that BCD is a triangle. If I get B and D, I can then work out. Well, actually what I want to do is, I don't want to get that. I want to get, sorry, I don't actually want to get that. I want to get in order to get, so we want BCD, this angle here. So I got another way. We're going to use, we need to get that, because angle at the center equals 2 times the angle at circumference. It's this shape here. Okay, angle at center equals 2 times the angle at circumference. So I need to get this angle BOD. Well, that's easy because I know that OBD was 22. So because I know that this is 22, this one will also be 22 because it's the same, right? I did orange minus yellow, and I'm doing orange minus yellow to get this one was 22. And so I could get BOD because of these, because you can see that if BOD, this triangle here, because these are both the radius, OB and OD are the radius, those will be, those are equal lines, so these will both be 22. So in other words, we already got that OBD is 22, so ODB is also 22, which means we get BOD. So that's how we're doing it, saying BOD is equal to 180 minus 44, those two angles added together. So 136 degrees. And once you've got that, we know that that angle at the center is 2 times the angle at the circumference. So that means BCD is 136 divided by 2. So BCD, so let's just practice giving reasons. So BC, yeah, B, O, B, sorry, B, C, D equals 136 divided by 2. Angle at center equals 2 times angle at circumference. Okay, so we get 136 divided by 2, which is 68. Okay, finally we need to get BED. BED, well, BED is easy because it's a cyclic quad. So angles of a cyclic quad add up to 180. So if this is 136, then BED is 44. So BED equals 44 degrees, opposite angles of cyclic quad supplementary, adding up to 180. Okay, so that's 44. Give a reason why ABOD is a cyclic quad. ABOD. Oh, well, that's easy because of that this is 90 and this is 90. ABOD. So I'm talking about the two orange ones. So we're talking about this ABOD. So we're talking about this here. And we notice that's 90 and that's 90. And we know the opposite angles of a cyclic quad are 90 degrees. Add up to 180. Opposite angles. Opposite angles are supplementary. And so not just 48, so not just 90 and 90, but also we notice this was 48 here. This one here, just coloring in orange, that's 48. And then this one we got was 130, 132. So that would be supplementary. 2 plus 136. Have I made a horrible mistake here? Oh, that's 136. Actually, that's 132. Where have I made a mistake? The 66 plus 66 is 130. Yes, 66 plus 66 is 132. Ah, okay. So BOD is actually BOD, sorry, is these are 66. I made a mistake. The yellow ones are 66. I don't know why I wrote 68 here. Okay, so you go back in the video where I wrote 66 here. I don't know why I suddenly wrote 68 there. That's weird. I just did it again. It's been a long day. 66 and 66. I don't know. So I wrote the right angle there, and then when I wrote it in here, and so that would have made everything wrong. So 66, 66. And so this ends up being not 136, but 132. Okay. That's still 66, which is fine. Yeah, 132 divided by 2 is 66. And so this is fine. This ends up being 132 here. So I was just showing, okay, the ones in black that I'm coloring in, that is 132, and that's 48, which adds up to 180. That also shows why the opposite angles of a cyclic quad are supplementary. Sorry about that. Okay, so just go watch the video again, see where I went wrong with my calculations or writing something down. But all of the reasons and everything are fine. Okay, so that's that question. Let's look at another one. Okay, so here we've got sailboats and all sorts of things. So here's a tangent. And so we know y is 55 degrees because of, x is 55 degrees because of our sailboat theorem. Right? So we have a sailboat. So when your tangent makes like a sailboat, then that is equal to that. So x is equal to 55 degrees. Now we don't say sailboat theorem. Tangent, it's tangent chord theorem. tan chord theorem. Y is, it's a cyclic quad, so they add up to 180. So y equals 115 degrees. 180 minus 60, and that is because of opposite angles of cyclic quad. Okay, supplementary. You can write supplementary if you want, I think, but not that important to do that. Okay, let's just look at question 7 quickly. And then we'll be done. Okay, Andre stands on a level ground, 295 from a vertical tower. Okay, so let's make this the vertical ground. Sorry, the ground. Let's make this the tower. So here's old Andre here. And he is 194 away. And the tower is 55. What is the angle of elevation? So we need to calculate the angle of elevation. So in other words, what's this angle here? Okay, so remember SOHCAHTOA, because this is a right angle because it's vertical. What is this angle? The angle of elevation we want to work out. Well, this is opposite to that angle, and this is adjacent. So O and A, knows, remember SOHCAHTOA. If you don't know what I'm talking about, you just need to refresh on your trig basics. But what we know is we have O and A, which is the TOA, so tan. So we're looking at TOA. So tan of the angle, theta, is equal to opposite over adjacent, which is equal to your opposite, which is 55. And the adjacent side is 194. Now you just put this in your calculator. Tan to the minus 1 of 55 over 194. Which you get. Okay, so I'm going to go out of this. And you're going to write the answer down. I'm just going to put it on my calculator. So I'm going to go out of this. And share my calculator when I've opened it. And just to make sure you get the same thing. So 55 over 194 is what we need to get. Okay, so let me just open up my calculator. Oh, I can't minimize unless if I'm recording. It's weird. Okay, let's see. Okay. Share screen and share. So it was, oh gosh. So we go shift tan, because it was tan theta equals tan to the minus 1 of, what was it, 55, I think, over 194. Equals, so your angle of elevation is 15.8, right? 3 significant figures. 1, 5, 8 would be 3 significant figures. Okay, it was 55 over 94, wasn't it? No, 294. Ugh. Sorry. Oh, what a day. 10.59. So we say 10.6. We want 3 significant figures. Because if we're dealing with GCSEs, which is Cambridge usually is GCSEs, it's 3 significant figures. Okay, so that's it. I hope that helped.